Okay, 14 is no longer in the syllabus. Here we go. So we've got some surd work here. And all you need to remember is when you've got a surd like this, it's the little 2 on the bottom that moves around to the front and the 3 stays where it is. That's all you have to remember, okay, when you've got a fraction. So that's 16, and that becomes a square root, and the 3 stays exactly where it is. All you have to remember for that one. So square root of 16 is going to be 4, and 4 cubed is 4 times 4 times 4, which is 64. So again, you know what you don't. It's a nice little question, I think. I'll just go through a few more with you. If you had, say, 8 to the third, that's a 3. That would then become the cube root of 8 to the 1. And the cube root is saying what times what times what is 8. Well, in that case, it'd be 2. 2 times 2 times 2 is 8. Another 1 just stays exactly where it is. Okay, so the top number stays and this comes round. That's just about it. The other thing we can do is with negatives. So if someone said, what is 8 to the negative a third? Well, when you change the sign, you cross the line. So that's the same as 1 over 8 to the third, which is 1 over the cube root of 8, which is just 1 over 2. So see how, without the negative, the only thing that's changed is 2 and 1 over 2. Yeah? We cross the line when we change that sign. So that's kind of coming back to your surd rules. If you get x to the negative 2, that's the same as 1 over x squared. Yeah, not too much in that. Function, great. So we're just substituting in into our function. We should remember from last time that that's the height of our function, so don't need to know it for this, but I'll just show you. So the sine wave is doing this. And this is saying there's 3 waves inside of 360, so that means that goes up to 120. And the 4 in front means it goes to 4 to negative 4. The full height's 8. 8 divided by 2 is 4. So this is saying what happens when you substitute in 90 into that. Okay, so f of 90 is equal to 4 sine 3 times 90. So yeah, what do we get for 90? Now, I can't just look at it, unfortunately, because now my wave here, that middle number is going to be 60. My 90 number is going to be, looks like it's going to be down here in the middle, doesn't it? Because between there and there, that's 60, half of 60 is 30. So it's looking for that number there. So actually, you know what? I can just read it off a little graph I've drawn, and the answer would be negative 4. But say you weren't able to do that, okay? You could say, right, well, f of 90, if I was to do sine 390, that's the same as 4 sine of 270. And then you could say, well, I didn't know how to draw this, I wasn't really sure. But you should be able to draw your regular sine graph, shouldn't you? Your regular sine graph, which does this. And then at 270 degrees, you should know that there's 90 degrees. That's 180. And this one is your 270. So again, at 270, it's here at negative 1. So that's the same as 4 times negative 1, which is negative 4. But you could also actually have drawn it out and just read straight off the graph. So for that one, you're getting a mark for your substitution. So again, you're not sure what you're doing. You should know, as with any substitution, you replace the x's with the number. So you've taken out x for 90, substitute it over here, and then you've evaluated it. So that's a bit of a mean one. Usually it's a nicer thing than a sine, cos, tan kind of function. Usually it's a 4x squared or whatever. So slightly mean. However, as with all these things, there's marks to be had all the way through. And if you weren't sure about this last bit, you should have been able to say, I can substitute in 90 and get my marks for the substitution. Right? And nearly there. Sketch on a graph. So I sketched the graph of this. Clearly show the coordinates of the turning point and the point of intersection with the axis. Okay. So again, I'll take my incredibly bad lines here. Okay, so what do we want to find out? We want to find out the turning point would be good, the roots would be good, and the intercept would be good as well. So the turning point, we should be able to look at this and take my turning point as 1, 4. Okay, change the sign, stays the same. Change the sign, stays the same. So right away I'm thinking 1, 4, there we go. And I should know the shape. I've got positive, if I multiply this out, I've got positive x squared. So I should be thinking that it's doing something like that. It's a happy graph, okay? So I've got no roots to worry about. If there was roots to worry about, it'd be a factorizing type thing, yeah? But I don't have any roots because it's not crossing the x-axis. And then where is it going to cross the y-axis? Well, it'll cross there when x is 0. So I just have to substitute that in. So it's going to be 2, 0 take away 1 squared, plus 4. So that's 2 times negative 1 squared is just 1, plus your 4. So 2 times 1 is 2, add the 4 for 6. So I'll mark that on there as 6. I'll say 0, 6, just to be proper. My turning point is 1 and 4. So let's have a look at the marking scheme. You're going to mark for your turning point, so we should really all know the turning point. Yeah, change the sign stays the same. You're going to mark, you're also okay just to say 6, but 0, 6 to be safe. And you're going to mark for a half decent sketch, I think, with the shape of it as well. Okay. Yeah. So knowing the coordinate, being able to actually draw it. So good ratios 1, 4. You're not drawing it down here. You're not drawing upside down. Yeah, a nice little mark as well. So we're on to the last question now. We'll do a last video for that, and then that's sorry, two questions, and then that's us nearly done. Yeah, but I'll do a wee recap on the last video. Okay, so nearly there.